Hello and welcome to another video tutorial in ANSYS Workbench 18.1. In this video we are going to look at a pressure vessel. In this particular case we have a pressure vessel with an overall length of 3 meters. We have the end caps of radius 1 meter to the outside and an inside radius of 0.8 meters. We are going to determine the hoop, axial, and radial stresses in the vessel due to an internal pressure of 1 megapascal. I hope you enjoy the video. So, after opening ANSYS Workbench 18.1, we left-click on Static Structural and drag it to the Project Schematic window and up to the green box and let go, and this will bring up our Task menu. We'll create our geometry first and just use the default engineering data or engineering materials. So I'll double click on geometry. After Space Claim has opened, we can close the pop-up window. I'll change my sketch plane to a different plane and draw on the XY plane. I will look at a plan view of that. My units should be in metric, but the default will be millimeters, so I'll go ahead and change that to meters. So I'll click on units, metric, drop down and select meters. Now I'll scroll to the bottom where I can type in 0.1 meters, and now I'm ready to begin to draw my geometry. To do this, I'm going to use the sweep arc command to generate the curved ends. So I'll click on that. To do this, you click the center first, then you enter in your second point, and I'm going to type in my radius so that it is exact of 1 meter, enter. And now I swing that around 90 degrees and click the end point. We can now create the inside surface, so I'll click the center again, I'll pull down and I'll type in 0.8 meters, enter, roll up around to the x-axis 90 degrees and click enter. I can now blow this up a little bit, and control middle mouse button will let me bring it back into the window. I can click on my line and I'll create a line to close these end caps. Now I'm ready to make a copy of this and have my other end of my cylinder. So I will go ahead and click this geometry. After escaping out of everything, I can highlight this geometry and do a move. So I'll click on move and I will do a control move. After selecting the vertical axis and hitting control, I'll slide this up, and I'm going to slide it up 2 meters. So 2, enter. Now I can, while I have this, I can rotate this 90 degrees. So not holding the control button, I simply rotate that and type in 90 degrees. And I now have my end plates, the curves for them drawn. I can hit escape and zoom in a little bit, control middle mouse button to bring it to the middle. I'm in sketch mode, so clicking on my line, I can close this by clicking and then clicking my line there, escape, holding over the point and clicking on the point, escape, and escape again takes me out of line mode, and I now have a 2D picture of my geometry. I'm ready to rotate this. In this particular model, we're going to look at a quarter of the cylinder. So I will come to 3D mode and I'll select these 3 surfaces. Select the first one with a left click, control click, and control click. And now I'll click on the pull, and I'm going to come down here and click on the revolve. And what you do with this is you click on the revolve and then click the axis that you want to revolve about. So I'm going to rotate this a little bit so I can see the revolve. I'll click on the revolve button, click the Y axis, and now I will rotate this around, and I'll simply type in 90 degrees, enter. And you can see that this left me with a 90-degree hole. And so if I want to go the other way and rotate this in the other direction, I can undo that command, and that will bring me to using the axis and giving me the eighth or the quarter of the circle that I wanted. So I can now hit escape, and that is my geometry. I don't have anything else to build in the geometry, so I can go ahead and minimize this window and open the model. And this brings up ANSYS Mechanical. So after opening ANSYS Mechanical, our geometry has been imported. We can click on the drop down to see that we have one solid, and the geometry looks fine. So we'll close that. We don't need to do anything with coordinate systems. So we'll look at mesh. We're going to do a swept mesh on this body, but to begin with, I'll right click and left click generate mesh to just see what ANSYS gives me as a default mesh. And you can see that the default mesh is made up of triangular elements, and I don't have much symmetry. The mesh is kind of random, and I can generate a much cleaner mesh than this by doing a swept mesh. So I'll come to mesh, right click, insert, and then click on method. I'll click on body select and select the body and click on apply. Now I need to come up and look at the method part, and right now it's an automatic. I want to change that to sweep, so I'll click over here to bring up the drop down, open the drop down, and click sweep. Now I'm going to be doing a swept mesh, so I come down through the other settings, and it says that the source and target selection is automatic. In this model, I want to select my own source and target, and so I'll click on to bring up the drop down, click manual source and target. Now I'll come over here and select on the surface selector. I'll select this surface, rotate it around, and control click the second surface. And now these will be the surfaces that I want to use in my source and target. It doesn't really matter which one of these I use for the source or the target, because they're pretty much symmetric. So I'll go ahead and pick one of them for my source. I'll rotate, click the other one for my target. Now in terms of my element type, the mesh type, right now I'm using quadrilaterals and triangulars, and I want to just use all quads. So I'll click the drop down, open it up, and select on all quads. Now the number of divisions, this represents the number of divisions that the mesh will be broken up into in the 90-degree rotation. So I'll click on this and increase the number to 10 and not use the default. The other settings in the details of the sweep method are okay. So I'm going to come up and right click on mesh and generate mesh. You can see now that I have a much nicer looking mesh, but it's still relatively coarse. So I'll come over here, and in the details of mesh under relevance center, I will left click to bring up the drop down, click, and then scroll down to fine and click fine. Again, you can see that the mesh has turned yellow, which means it needs to be updated. So I'll come and click the update button, and I now have a really nice looking mesh, and that's what I'm going to go ahead and use to solve the problem. So I'm ready to enter in some boundary conditions so I come to static structural, right click, insert, and I'm going to insert frictionless supports. Frictionless support is the same as an axisymmetric boundary condition in ANSYS Mechanical. So I'm going to click on this surface, rotate around, control click the other surface, and now these are the two end conditions or surfaces that I want to be like axisymmetric. And in this case they'll be frictionless support, so I click apply. Now I'm ready to enter my pressure, and so I'll right click on static structural, insert pressure. Now I'll come and select these surfaces, so I'll click the first surface, control click the next two surfaces on the inside of my cylinder, click apply. And this is asking me for the number of pascals. I'm going to have 1 e to the 6th pascals, enter. So I now have my pressure, I have my axisymmetric boundary conditions. You can see all of that by clicking on static structural. Now from experience I know that if I go to solve this model as it is, it's going to give me an error saying that there is a large deflection in the y direction and that my model is unconstrained. And so what I need to do is I actually need to come and fix one point on this structure from moving in the y direction. And the best way to do this is to right click on static structural, insert displacement, and probably click this end node here. So I'll come up to the vertex, select, click this end vertex, click apply, and I'm going to fix that in the y direction. So I click enter. Now I can come back to static structural and look at my pressure, look at my boundary conditions and my end condition, and I'm ready to go pick my solution outputs. So I'll right click on solution, insert, and I'll look at the stresses, and I'm going to want to, in this case, have the maximum principal, the middle principal, and the minimum principal. The maximum principal will be the circumferential stress, because we know in cylinders that circumferential stresses or hoop stresses are the largest principal stress. So I can click on that. Now to bring up these others, it's easier to just come to the drop down and click the middle principal, click the drop down, and the minimum principal. So I'm ready to go ahead and solve this. I'll right click on solution and click solve. So after the solution has been obtained, I can come and look at my principal stress and see if it actually makes sense to me. And so, like I said, this maximum principal stress will be the circumferential or hoop stress, and this makes sense as we know that the hoop stress is largest on the inside surface, and that's what we're seeing here. I can look at the middle principal stress, and I can tell that this is the axial stress, and my minimum principal stress I can tell is my radial stress, because this inside stress here is equal to the negative of the internal pressure. And so we've done a successful model of a quarter cylinder with an internal pressure. I hope you've enjoyed the video.